Stepping outside in Andhra Pradesh and Telangana lately.
Yeah.
Wow, it feels less like summer and more like, well, entering an oven.
It really does. And this isn't just about feeling uncomfortably hot.
Right, it's this complex interplay, isn't it?
Yeah,
Geography, climate, all leading to these intense heat waves.
absolutely. It's a whole system at play, and understanding the nuts and bolts of why these areas are so susceptible is really key, especially when you think about the effects on, well, everything.
Okay, so let's dive right into it. We're using a detailed report from the Hindu as our guide today.
Mm-hmm.
And the aim is really to unpack the why behind this extreme heat for you.
Yeah, get to the bottom of it.
So whether you're maybe a UPSC aspirant needing a solid grasp of this for exams, or maybe you're just keen on staying informed or, just curious, this is for you.
Definitely.
We're going to explore the geographical factors, the climatic ones, basically what sets the stage. Then we'll get precise about how the IMD, the India Meteorological Department, actually defines a heat wave.
Right. And after that, we'll look at the impacts, the very real effects on health, the economy, agriculture, the environment.
It touches everything.
It really does. And we'll wrap up by looking at some of the steps India's taking, the initiatives to tackle this growing challenge.
Sounds good. So let's kick things off with geography. How does the actual physical location, the land itself, in Andhra Pradesh and Telangana contribute?
Well, latitude is a really fundamental factor.
Okay.
Their proximity to the Tropic of Cancer means that, especially in summer, the sun's rays are hitting these regions very, very directly.
Almost straight down.
Pretty much. Think of it like the sun being almost overhead. That means intense solar radiation, a lot of energy pouring onto the ground and heating it up fast.
Okay. So that angle really matters for how much heat gets absorbed.
Precisely. And then you've got the terrain itself. Take Telangana, a big chunk of it is the Rocky Deccan Plateau.
Right.
These kinds of landscapes, barren, rocky, they absorb a lot more heat compared to, say, areas with lots of vegetation or moist soil.
Makes sense. Dark, dry surfaces just soak up the heat.
Exactly. And the black soils you find a lot in these areas, they're known for holding on to that heat. So that contributes to keeping those daytime temperatures persistently high. Now, if you contrast that with places that have, significant green cover or irrigated farmland,
You see a difference.
definitely, you get a localized cooling effect. That's thanks to evaporation water evaporating from plants, from the soil. It cools the air around it.
Kind of like nature's air conditioning in a way.
Sort of, yeah.
What other geographical things are at play?
Well, being landlocked makes a big difference. Telangana, for instance, is mostly landlocked, so
Okay.
it doesn't get that moderating influence you see from large bodies of water like the sea.
Yeah, coastal areas always seem a bit milder in extreme heat, don't they?
They generally do. Water takes much more energy to heat up than land, and it cools down slower. Plus, you get evaporation off the water surface cooling the air. Landlocked regions don't have that buffer, so they tend to see more extreme temperature swings and a higher chance of really intense heat waves. We see this pattern elsewhere in India, too, like in the north-central part.
And I guess cities add another layer to this.
Oh, absolutely. The urban heat island effect. It's a major contributor, especially to localized spikes in temperature.
The concrete and asphalt.
Exactly. High density of people, buildings, roads, all these materials absorb and then trap heat. And often there's not enough vegetation in cities to counteract that. It just amplifies the effect.
Okay, so the land, the cities, they set the stage. What about the weather patterns, the climate factors?
Yeah. So one big factor is the lack of really significant pre-monsoon rain.
Okay, dry conditions beforehand.
Right. Dry conditions mean less moisture in the ground, so you lose that natural evaporative cooling we talked about. And if you combine that with minimal cloud cover,
More direct sun gets through.
exactly, more solar radiation hits the surface, driving up temperatures. It's sort of a double whammy,
Yeah.
dry land and clear skies. Then there's humidity. High humidity really changes how we feel the heat.
Oh yeah, that sticky heat.
Precisely. It makes it harder for our sweat to evaporate, which is, our body's main way of cooling down.
Right.
So the heat index, what it actually feels like, goes way up, often much higher than the thermometer reading. I remember reading something about how even a small increase in humidity can drastically increase the strain on your body during hot weather.
That makes sense. You just feel like you can't cool off.
Exactly. And then weak winds don't help either.
How so?
Well, stronger winds help mix the air and disperse the hot air building up near the ground.
Yeah.
If the winds are weak, that hot air just kind of sits there.
It lingers.
It does. And sometimes you get stable atmospheric conditions, like temperature inversions where warmer air sits on top of cooler air near the surface.
Hmm.
That can trap the heat even more, making heat waves last longer and feel more intense.
Like putting a lid on it.
A good way to put it. And if we look higher up in the upper atmosphere, certain patterns are key. Anticyclonic flows, for example.
What are those?
They're basically large, stable, high-pressure systems. They tend to bring clear skies, very dry air, and descending air masses. As that air sinks, it gets compressed.
And heats up.
And heats up, yes, which further warms the ground below. So sinking air in this situation is definitely not helping.
Okay.
And even larger climate patterns like El Niño can play a role.
How does El Niño connect?
Well, El Niño can weaken the monsoon trade winds. That often leads to less cloud cover and reduced rainfall across parts of India during certain periods.
Circling back to the dry conditions and more sun again?
Exactly. It's all interconnected. And of course, we can't forget the Lu.
The infamous Lu winds.
Those hot, dry, dusty winds that sweep across northern and central India in the summer, they just add another layer of intense heat.
Right. Okay, so we have the geographical setting, the climatic triggers.
Yeah.
But how does the IMD actually define a heat wave? When does hot weather officially become a heat wave?
That's a good question. The India Meteorological Department, the IMD, has specific criteria. Generally speaking, it's about a period where temperatures are abnormally high compared to what's usual for that place and time.
So it's relative to the normal conditions.
Mostly, yes. But there are also absolute thresholds. It depends on the region. For the plains, a heat wave is declared if the maximum temperature hits 40 degrees C or more.
Okay.
For hilly regions, the threshold is lower, 30 degrees C or more.
And coastal areas, you mentioned they were different.
Yeah, coastal stations are a bit more complex. A heat wave is declared there if the maximum temperature departure from normal is 4.5 degrees C or higher, and the actual maximum temperature is at least 37 degrees C.
So it needs both.
Mm-hmm.
A significant jump and a minimum high temperature.
Exactly. That departure from normal is a key metric everywhere, though. A heat wave is generally when the departure is 4.5 degrees C to 6.4 degrees C above the seasonal normal.
And if it's even higher.
If the departure is more than 6.4 degrees C above normal, it's classified as a severe heat wave.
Okay, that makes sense. Bigger jump, more severe.
Right. And they also have criteria based just on the actual temperature reached. If the maximum hits 45 degrees C or more, that's also declared a heat wave, regardless of the departure.
Wow, 45 degrees.
And if it reaches 47 degrees C or higher, that's automatically a severe heat wave.
Those are really dangerous temperatures.
They absolutely are. And one more thing for an official declaration, these conditions usually need to be met at a minimum of 2 weather stations within a meteorological subdivision for at least 2 consecutive days.
So it can't just be one station for one day. It needs some spread and persistence.
Exactly. It indicates a broader, more sustained event.
And when do these typically happen in India?
Mostly between March and June. May is often the peak month for heat waves.
Right before the monsoon, usually.
Typically, yes. And it's worth noting, despite, the very serious impacts, heat waves aren't currently classified as a natural disaster under India's Main Disaster Management Act from 2005.
That is surprising, given everything we're discussing. So speaking of impacts, let's move into that. It's clearly much more than just feeling uncomfortable.
Oh, absolutely. The consequences are really far-reaching. The most immediate and maybe the most critical is the impact on human health.
Yeah, that has to be paramount. What are the risks?
Well, prolonged exposure to extreme heat can cause a range of problems. It starts with things like heat cramps, maybe some swelling, fainting.
Okay.
Then it can progress to more serious heat exhaustion. And the most dangerous is heat stroke, which is a life-threatening emergency, needs immediate medical help.
A real spectrum of illness, then. Who's most at risk?
Generally, the elderly, infants, people who have to work outdoors, like construction workers, farmers, people in low-income groups who might not have access to cooling, and anyone with pre-existing health conditions.
Vulnerable groups are hit hardest.
They often are. There was a report, Heat Watch 2024, that highlighted a really concerning statistic.
What was that?
It reported 733 deaths attributed to heat stroke across 17 Indian states just between March and June this year.
733. Wow.
Yeah.
That really drives home the human cost.
It does. It shows how deadly these events can be.
And beyond health, what about the economy?
The economic hits are substantial too. Think about sectors like construction, mining, power plants. Anywhere people work outdoors or in hot indoor environments.
Productivity must drop.
Definitely. Worker efficiency goes down and the health risks go up significantly. Some studies have estimated that laborers doing heavy physical work can lose something like 162 working hours a year because of extreme heat.
That's a huge amount of lost work time.
It really adds up. And it's not just outdoor labor. Consider aviation.
Flying. How does heat affect that?
Well, high temperatures make the air less dense. Thinner air means planes need longer runways to take off.
Oh, okay.
It basically simulates being at a higher altitude. So it increases operational costs for airlines, uses more fuel. It's one of those less obvious economic impacts.
That's fascinating. I never would have connected those dots. What about damage to the environment itself?
Heat waves definitely worsen environmental problems. The risk of forest fires goes way up.
Because everything is so dry.
Exactly. Dry vegetation becomes tinder, and the high temperatures make ignition easier. These fires damage ecosystems, release carbon, and can threaten communities. The Forest Survey of India estimates over 20% of India's forest area is vulnerable.
That's a large area.
It is. Plus, the intense heat just accelerates evaporation from lakes, rivers, reservoirs.
Making water shortages worse.
Precisely. Less water available affects everything: farming, livestock, drinking water supplies, ecosystems.
And that leads us directly to agriculture, doesn't it?
Yeah.
How does it impact our food supply?
Hugely. Extreme heat puts immense stress on plants. It can stunt their growth, even kill them, and it definitely leads to lower crop yields and often poorer quality produce.
Are certain crops more affected?
Kharif crops like rice, which are grown during the monsoon but can be affected by pre-monsoon heat, are particularly vulnerable in these regions. It's a serious threat to food security.
Is there data on the yield reduction?
Yeah, there's some striking data. One figure suggested that a 1% increase in heat wave frequency back in 2022 was linked to a 15% drop in crop yield overall.
15%? That's massive.
It is. And for specific crops like wheat, research shows that every degree Celsius rise above 30 degrees C during the crucial grain filling stage can cut yields by 3 to 4%.
It really paints a concerning picture, doesn't it? This web of interconnected impacts.
It really does.
So given all of this, what's India doing? What initiatives are in place to try and tackle these heat waves?
Well, the government is definitely taking it seriously. There's been a proactive push to update and implement heat action plans, or HAPs. I think they're across 23 states now.
Okay, heat action plans, what do they involve?
They're pretty comprehensive. They usually start by creating a heat profile for the area, looking at past data, temperature trends. Then they do vulnerability assessments, figuring out who and where is most at risk.
Identifying the hotspots and vulnerable populations.
Exactly. And based on that, they develop response plans. These plans outline specific actions for before, during, and after a heat wave and assign clear roles to different government departments: health, water, power, disaster management, etc.
So it's about coordination and preparedness.
That's the goal. And the IMD plays a big part too, issuing those color-coded, impact-based heat warnings. They do this jointly with the National Disaster Management Authority.
To give people and officials a heads up.
Right. Early warning is crucial. Then you have initiatives focused on water, like the Jal Shakti Abhiyan.
Which focuses on water conservation.
Yes, and restoring water bodies. Making sure there's enough water available during heat waves is obviously critical for drinking, for cooling, for everything.
Makes perfect sense. Water is key.
Absolutely. And the Smart Cities mission also plays a role. It encourages things like increasing green cover in cities, using water-sensitive urban design, building climate-resilient infrastructure.
Like creating parks and cool zones.
Exactly. More green spaces, maybe designated public cool zones where people can escape the heat, trying to make cities more livable in extreme temperatures.
Okay.
And there are also specific cool roof and urban cooling initiatives starting to take shape.
Cool roofs, what does that involve?
It involves using reflective paints or materials on rooftops. Hyderabad, for example, has a program promoting this, and studies show it can significantly lower indoor temperatures.
That sounds like a practical, direct measure.
It is. And some states like Telangana, Gujarat, Maharashtra are actually starting to include cool roof standards in their building codes, especially for public housing.
So, building resilience right into the infrastructure. It sounds like there are efforts happening on multiple levels.
There are, yeah. It's a complex problem, so it needs a multi-pronged approach.
Okay, so just to sort of bring it all together.
Yeah.
We've seen how geography, things like being near the Tropic of Cancer, the Rocky Deccan Plateau, being landlocked, combines with climate factors like low pre-monsoon rain, weak winds, maybe El Niño effects.
To create this kind of perfect storm for intense heat waves in places like Andhra Pradesh and Telangana.
Right, and the impacts are huge on health, the economy, farming, the environment. It's not just hot weather.
Definitely not. The consequences are significant and deeply interconnected.
And we've also touched on India's response. The heat action plans, the warnings, water conservation efforts, cool roofs, trying to make cities more resilient.
Yes. A lot is happening, though the scale of the challenge is immense. And, considering this whole intricate web of the geography, the climate, the human factors, it really leads to a question for you, the listener.
Okay.
Thinking about everything we've discussed, what do you believe is the single most crucial element for building long-term resilience against these increasingly severe heat waves in India?
That's a great question. There's no single easy answer, is there?
Not at all.
Yep.
It requires thinking about all the different pieces.
Definitely something to mull over.
Yeah.
And for those of you listening who are preparing for UPSC exams, we really hope this deep dive gave you some valuable context and points on this topic. It's certainly relevant for both mains and prelims.
Absolutely. Hope it was useful.
And for everyone tuning in, if you found this discussion informative, please do hit that like button, subscribe if you haven't already, and maybe leave a comment. Let us know your thoughts or any questions you still have.
Yeah, we'd love to hear from you.
And just to mention again, the primary source we drew upon for today's discussion was the excellent reporting found in The Hindu.